All right, why don't you start by just introducing yourself and telling us a little bit about your background?
So I'm Billy Kelham. I'm a structural engineer. I work for a company called WSP, which is a global company. It's around 30,000 employees worldwide. But I'm based in our London office, which is the UK head office. I've been there 5 years, where I came as a graduate straight from university, and then since progressed through to being a senior engineer.
We're talking about the Unity Place project. Can you kind of give me a short background on the project and what we think were some of the unique aspects about it, and something that might be of interest to our readers?
Yeah, so Unity Place is the new Santander headquarters in the UK. Um, it's a reinforced concrete frame office build where 5,000 employees will be working when it opens. I think it's due to open this month now. It's been pushed back slightly, but it's a project I've been working on since I started WSP 5 years ago. So we've been involved from design all the way through its construction and through to its completion actually this month. So it's wanting to be like a new central state-of-the-art modern hub office build. They're closing 5 existing offices and bringing all of the employees from those offices into this new hub. It's classed as a ground scraper because it's only 10 stories tall, but it's around 100 meters in width. So they've made use of the floor area they have available and got like a low-rise office build. One of the key features is its sustainability. It's the UK target for sustainability is something called LETI, which is the London Energy Transformation Initiative, and they set out these guidelines for new builds to adhere to. So even though we designed Unity Place in 2018, it's already surpassing the 2030 targets for carbon, which is actually a really popular topic at the moment. It's like a joint vision between the client, all the contractors, the architect, and us to try and make this building as sustainable as possible. So yeah, no, it's not just an office as well. The whole ground floor and level 1 is open to public access, where there's they've got restaurants, craft beer pubs, roof terraces, yoga rooms. So they're trying to make it like a hub for the community. Its location is right next door to Milton Keynes train station, so they're wanting it to not just be a typical office block that's just for the Santander staff, but also a hub for everyone else as well. So yeah, I think it'd be good once it's open. I feel like it's been a long time coming, but yeah, hopefully
Yeah,
next month.
5 years on a project. That's a lot of work. So you
Yeah,
mentioned the sustainability aspects, and I believe the article we're going to be writing this about will be on our sustainable engineering issue. Can you describe a little bit of how you guys met those sustainability goals, some of the unique features and ways you're able to do that?
it's like a 3-pronged approach, I think. The 3 main features that we save a lot of carbon on. The first one is the raft foundation. So it's basically a big meter deep concrete slab in the basement that all the columns sit on. We designed this to be flexible. So when we excavated the 2-story basement, the clay that it sits on, when clay is unloaded, which happens during the excavation process, it almost behaves like a sponge. So once it's been compressed for all these years, once it's unloaded, it wants to expand and swell up. So we designed the raft foundation to move with this swelling instead of trying to resist it. So this meant we could have a much thinner raft foundation. And given the size of the raft being 100 meters by 150 on plan, any saving we made to the depth was huge overall. One of the other things was the crane bases. So we had 4 cranes on site throughout the build. Generally, these are supported on piled foundations, so deep columns that go into the ground to stop the cranes from overturning when they're in use. But we optimized the raft foundation and use that as a pad in a temporary condition. So instead of having the piles, we just built an area of the raft foundation to support the cranes, and then this formed part of the basement in the permanent condition. So we think we saved around 32 piles on that. And then the final thing was the floor slabs in the offices. These were made from PT, which is post-tension slab. So it's concrete still, but it's much thinner than your typical reinforced concrete slab. If it was in reinforced concrete, you'd be looking at a depth of around 400 millimeters. But by using post tension, we were able to reduce this down to 275. So 125 mil was saved over 53,000 meters squared. And also all the concrete we used in Unity Place was 50% GGBS, which is a cement replacement. So the majority of the carbon in concrete comes from the cement. So when this is awed, very important cement, it releases a lot of carbon dioxide. So we replace 50% of this in our concrete mix with this GGBS, which is a byproduct of the steel industry. So when steel's made, this is the slag that's left in the furnace. So it's already present from the steel industry. So we take that, and instead of putting it to waste, we put it within the concrete to save having to ore the cement. This makes concrete more greener. So yeah, that was a three or four main things for how I made Unity Place a bit more sustainable.
Yeah, that's great. So also there was a you guys created a shared model, almost like a BIM model, if you will. Can you tell me a little bit about that and why you decided to use that, and how effective was it, and how did it work?
It's brilliant. I think because when we started on site, I think COVID restrictions in the UK just came into place a month after we started the build. So none of the design team were allowed to meet up in person. None of us were allowed to go on site for the first 7 or 8 months, I think it was. So I know everyone had to do it, but everyone was on these calls trying to explain your ideas. But we made it so much easier by having one model that had the structure in it, the architect's model, all the mechanical engineering. So you could easily see if they're referring to some pipe work from an MEP pump that had to go through a floor slab that was clashing with a column or something. You could see it in 3D, and then it's easier to get solutions that way instead of working on 2D plans. So yeah, it was much very time saving. I think just because you weren't there in person, it was all online. It really benefited.
Will this be something you'll continue to do, even though now you can meet in person if you want to?
Yeah, definitely. It's really good for like clash detection. So when our structural model, we put something somewhere, we can then load in the architect's model or the mechanical engineer's model and make sure there isn't a beam going through where an opening should be, or a door isn't behind a column or something. Yeah, you can sort these clashes out in real time.
I think save a lot of time and effort and redundancy, right?
Yeah, and it cuts down mistakes massively.
Okay, so after doing this for 5 years and almost being done, what would you say would be some of the key things that you've learned that you're going to take from this project and use into your other projects, and perhaps some ideas that you could even pass on to your fellow colleague engineers?
I think the main challenges was partly through the interfaces between the different disciplines. So the facade on the building, how that interacted with the steel and the concrete, and the types of connections we had to use. So that was a good learning curve. What I'd pass on is, I think the PT option for offices, because we had a 9-meter grid column spacing, but being able to use this PT option and using the concrete cement made it much more sustainable. But we were also fortunate, given that it was a large floor plate, so we were able to use this cement replacement, which makes the curing time of concrete much longer. But because we weren't relying on floors below to build off the next floor, because you had such a large area, we were able to use this. But what I'd pass on is, I think, getting the involvement from contractors, like the concrete contractors, getting them on board as early as possible. So then you can arrange like pour schedules, and they can have an involvement in the design as well. I think it made a much more like holistic approach, having them and the steel contractors on board, because they're the experts in what they do. So I think they gave a lot of advice, and it made the construction a lot easier. I think that helped stay on schedule. So yeah, I think that'd be my takeaway, getting contractors on board. as early as
How
possible.
did you go about getting them on board? Was that just including them in these meetings and sharing
Yeah.
all with them?
So just after the design stage, they were involved before we even started the construction. So they had an input how they wanted it to be built, given it's them that was doing the work. So yeah, it's a good way of doing it.